Pat Kirpin from Cohesive Networks here to show you a new capability in the VNS3 network platform version 5.2.1. It is a capability for simplifying secure route-based VPNs. We call it traffic pairs. I've logged into my VNS3 controller. VNS3 controllers represent a family of virtual network appliances that can be configured as a simple single use case appliance for a VPC or VNet you have at Cloud Edge, or configured in a cluster to create a full distributed cloud network. Here I'm on the IPsec page, and for simplicity, I have one configuration here called My Customer. What traffic pairs do is provide you a really simple way to manage the routing instructions and the network ACLs for your route-based VPNs. When you have a route-based VPN, an internal virtual interface is created for exchanging traffic with your peer. Upon proper configuration and connection, an encrypted tunnel or security association exists between my device and the peer device, like this. Here we have an IPsec connection between my device and the IPsec peer at this address. And what's been created is a virtual tunnel interface called IPsec_VTI6. We can see that interface as well on the interfaces page, as well as access network utilities in order to examine it. The way most route-based VPNs work is you configure both sides to accept traffic from the world, or in IPv4 0.0.0.0/0. However, with this setup, a routing or ACL mistake could allow unintended traffic between the two networks. Fortunately, by default, no traffic is allowed to traverse. In conventional route-based VPN configuration, we now need to go create routes to the customer network and network ACLs allowing traffic to and from the customer network. If you only want to reach one address or subnet from your network, the conventional way isn't too hard. When you have tens or 20s of routes and possibly dozens or even hundreds of site-to-site connections, then it starts to get hard. An administrator could make what they believe is a local routing decision, and all of a sudden there is a customer or partner failure. Let's look at the standard way. My network is 192.168.201/24, and on the other side of the tunnel, it's 172.31.0.0.24. Let's pretend the customer wants to connect a corresponding address on their side to one on our side. We'll use the .10 address in each subnet. First, I'll need to put in forwarding rules for each way using my firewall. For simplicity, again, these are the only rules entered. And upon saving, I can see that they're installed via the operating system view. The traffic is now allowed. Now what I need is a route. I enter the destination for my route, and then I use our shortcut, which allows you to choose from among your route-based VPNs. So in this case, I pick My Customer as opposed to having to remember the specific VTI interface it uses. Again, with dozens or more connections, this makes it much easier to remember which interface to target. So that's it, the old school way. I have a route to the customer. It's installed in the operating system. I have my firewall rules allowing the traffic, but herein lies the risk. Another administrator could come remove the firewall rules or disable the route, thinking that it was only a local operation taking place. So let's remove our by hand approach and take a look at doing this with traffic pairs. Go back to my IPsec page. Traffic pairs work in the opposite direction. The VPN configuration defines a commitment to having a combined route ACL in place, and it can only be modified in the context of that site-to-site connection to your customer. I choose New Traffic Pair on the IPsec endpoint, and I enter my local remote subnet pair. give my traffic pair a name. And if I wanted, I could set up a ping to that host to ensure traffic is going over the network, preventing some partner devices from doing an idle timeout, which can be disruptive. That's it. Just like configuring a policy-based VPN, we entered a local remote subnet pair. Traffic pair gives us that same ease of use, better observability, and consistent security, creating the route-based VPN. Here we see our route has been created. Note, I can't delete or disable it outside of the VPN context. My firewall rules are installed into the operating system, which I can see via the operating system view. In this case, installed into the forward site-to-site VPNs table. They're not accessible to the UI or API for deletion, but if I need them to be disabled, I do it through the VPN context. I go to my traffic pair and I disable it. So now the route is disabled and the rules have been removed from the operating system. And if I want to bring them back, easily done by enabling the traffic pair. As I said, if you only have one endpoint, for example using the VNS3 free edition from the cloud marketplace, and only an address or two you're connecting, you might want to go old school. What's more interesting is when you need to federate customers' partners at scale with dozens to hundreds of VPN connections and that many or more routes ACLs to consider. In that case, with the simple knowledge of the two addresses you want to connect, VNS3 maintains the routing and ACL state for you, simplifying API interaction as well as DevOps deployment scripts, making it easier to deploy networks as code. In that case, take a look at VNS3 release 5.2.1 or higher and traffic pairs.